Hello everyone, I'm John Paulo Juarez, your first reporter in this subject. The topic assigned to me was hydrology, but before we go there, I would like to discuss a little bit about water resource engineering. So water engineering is the management of every part of the water cycle, from a drop of water falling out of a cloud as rain to the point at which it joins the sea. So water resource engineering also includes the planning and management of facilities. So here are some samples of said facilities. We have irrigations, canals, sewers, and drainage. So kanina mga facilities will be discussed by the upcoming reporters. A little bit of history. 5,000 years ago, people have already started manipulating water on a large-scale response to the need for irrigation in early agrarian society. So, ang pinakauna na mga civilization na nag-use og water system is the Egyptians. So, during ancient times, Egyptians were living a somewhat advanced way of living compared to other civilizations. In as early of 2500 BC, bamboo pipes were also used in China. So they used bamboo pipes as a way of distributing their water in their community. They used bamboo pipes in their water system. And then the Romans also, by 200 BC, have already utilized or used lead and bronze pipes in their water system. So Romans were famous in their Roman baths, and the most famous one is this water structure which is called the Roman aqueduct, which will be found in Italy. So Daniel Bernoulli. So si Daniel Bernoulli ang nag-formulate sa conservation of energy in hydraulics. So familiar naman ta ni tanan na ginatawag po nato Bernoulli's equation. After na formulate ni Bernoulli ang conservation of energy in hydraulics, this lead to the advancement of hydraulic engineering. So si John Smeaton pioneered the use of hydraulic lime in concrete using pebbles and powdered brick as aggregate. So si John Smeaton is mechanical engineer siya, pero siya ang pinakauna or the first self-proclaimed civil engineer. So gitawag po siya og father of civil engineering. So pagkaabot og 1850, engineering designs were still based mainly on rules of thumb. So they build structures without mathematical equations or complex math. They just build through experience lang. Then not until 1855 where there are many publications already about hydraulic experiments na nag-contribute to the field of hydraulic engineering na ginagamit till today. So enough about history. Let's proceed to my main topic, which is hydrology. So I assume all of majority sa to kay humana mag hydrology, so this is just an review. So what is hydrology? Hydrology deals with the occurrence, movement, and storage of water in the earth. Water covers about 71% of Earth's surface, and the majority of it is salt water. So bantog yan ay ginatawag na blue planet ang Earth because majority jud is water. So 96.5% of it is saline, 3.5% fresh water lang, then negative 68% is locked on ice, negative 30% is groundwater, and negative 2% are rivers, lakes, and streams. Ang hydrologic cycle or water cycle is the continuous circulation of water in the Earth's atmosphere. So, kung makita ninyo sa illustration, ang tubig from the surface and from the ground is padulong siya sa ocean, tapos gina-evaporate, then ginabalik na po siya sa land as precipitation. So ang cycle is continuous, walay hunong-hunong. So sa hydrologic cycle na ay forever. Precipitation. So, ang precipitation is any product of condensation of atmospheric vapor that falls under gravity from the clouds. So, tanan matagak gikan sa clouds is called precipitation. So, very common example of it is rain. We have snow, hail, and sleets. Ang sleets is murag yapon siya hail, but unlike sa hail na solid ang water droplets, sa sleets is medyo or partially melted ang droplets. So mo na siya difference sa duha. Next is movement of water in the water cycle. So we have infiltration, surface runoff, evapotranspiration, and storage. So in infiltration, water seeps into the ground but only less than 1%. So the rest is mag-adto lang siya sa surface, which is called the surface runoff. So sa surface runoff, this is the process where water runs over the surface of the earth. So ang tubig is mag-adto siya padulong sa mga irrigations, tapos sa lakes, water streams, then eventually balik na po siya sa ocean. Next is evapotranspiration. Evapotranspiration is the process by which water is transferred from the land to the atmosphere. So, pag ulan na ay tubig na magstay sa soil, tapos mag-evaporate, then na apoy magstay sa plants. So, sa plants, if na ay stored water niya mag-evaporate, ginatawag siya na transpiration. Ang tawag sa movement of water is evapotranspiration. Next is storage. So, dili tanan pod tubig is maadto pod or mabalik or ma-evaporate. In some places which they have cold climate or low temperature, water in the ground will be stored as ice or snow. And measurement of precipitation. So precipitation or rainfall has measurements. So na-classify siya into two. We have non-measuring gauges and measuring gauges. A good example of a non-measuring gauge is the Simon rain gauge. So rainwater falls into the glass bottle through the funnel. Then the water collected in the bottle is measured with the help of a standard measuring glass jar which is supplied within the rain gauge. The jar measures rainfall in millimeters. At each station, rainfall observations are taken twice daily at 8:30 a.m. and 5:30 p.m. So, gitawag siya ng non-measuring gauge because ang apparatus is the sole purpose of the apparatus is mag-collect og rainfall. So after ma-collect ang rainfall, ginabutang ang tubig sa graduated cylinder, tapos gina-measure siya periodically. So during 8:30 a.m. and 5:30 p.m. So after ma-measure, ginagraph siya for data. Next is measuring gauges. So under naman sa measuring gauges, naatay weighing bucket rain gauge. So it has a system by which the rain that falls into a bucket set on a platform is weighed by a weighing device suitably attached to the platform. So unlike atong previous apparatus, ang weighing bucket rain gauge is kaya na niya mag-measure og rainfall periodically. So kung makita ninyo sa illustration or sa picture, while nag-collect siya og rainfall, graph na pod niya ang given or ang rainfall collected. Next is, why do we need to measure precipitation? So, precipitation is very critical in hydrology. Ang data sa precipitation na collect kay ginagamit siya in weather forecasting. So, through data sa precipitation, mabalaan nato na if ever na ibagyo or mag-ulan, makabalota kung asa tong mga lugar na taas o water level or baba. So nowadays, ang ginagamit na is satellites and radars. So advantage ani is dako ilang scope of work. So dagan sila makover. However, ang ilahang ma-collect na rainfall data is not accurate. Kaya kailangan manggod na, because ang computation manggod sa rainfall or precipitation is complex. So that's why we still need to collect rainfall through this certain apparatus. So magamit ta og measuring o non-measuring rain gauges. And that concludes my report. Thank you for listening and God bless everyone.